All the best. The language can very easy. No, government language. We go to school. So I didn't make those one after 6 days. अपना चालू ही होता है सीधा फिजिक्स से ये सोच ही रहा हूँ तो 2 टेस्ट एक साथ नहीं पहले बायो में एक दिन और परसेंट दोनों बड़े हैं प्रॉब्लम जो उसको उतना बड़ा है दोनों बहुत बड़े हैं वॉल में भी प्रोजेक्ट है तो तरह क्या होगा भारत के नाम क्यों उनके तो समझ में आता है बायो में this physics chemistry geography physics chemistry and biology अलग हुए जैसे physics and bio मेरा weak subject I think should be able to do एक ऐसा दिन आएगा जिसमें दोनों के एग्जाम दो ऐसे दिन आएंगे हाँ 2 दिन होगा एक होगा मंडे और एक होगा ट्यूसडे को अलग से फिजिक्स उसके बाद याद नहीं इतना नाम भूल गए मेरे लास्ट पे तो मैथ्स एंड केमिस्ट्री इस दिन तेरा कोई सवाल तो मेरा मैथ्स समझे तो बहुत याद है फिर पता नहीं है क्या चल रहा है क्या समझ आता है volcanoes चलते ना तो प्लेटफॉर्म पे खत्म कर देंगे तो इसलिए क्या जरूरत वो तो मजा आता है स्ट्रीम में सिविक्स के जो 3 चैप्टर कर लिए सम रीजन अच्छा और एक पीरियड बढ़ा दिया हमारा वजनिज्म बुद्धिज्म का हमारा वैदिक पीरियड का कुछ बढ़ा दिया ना हाँ अपना भी वैदिक पीरियड में बढ़ा दिया था अनिल का अच्छी चीज है ये जो एग्जाम हमारे सन से लेके 9-10 होगा तो उसका मतलब हमें पीटी पीरियड मिलेगा हाँ मेरा भी पीटी पीरियड मिलेगा हाँ मेरा पीटी पीरियड तो ऊपर से 7वें पीरियड है तो क्योंकि हमारा ब्रेक 9-10 को शुरू होता है और पीटी ब्रेक के बाद होता है हमारा अच्छा पर ऐसा नहीं होना चाहिए किसी के एग्जाम में निकल जा रहे मतलब ऐसा होता है
lagi school kayak di apa ke provinsi asam berasal.
Hey, good evening. Where is my good friend? Your buddy, last week, oh, he's showing the throat. What does it mean? Not well. Chali, that's good. Now you are well. Shall I push you in the well? Cold was there or only cold? Fever. And now there's very slight symptoms I heard. Nobody in your vicinity. School. Your schools are all offline only, no online. Yes. Okay, let's proceed. So we have completed that landforms, correct?
Yes.
And started with
volcanoes.
Volcanoes, correct? Because you only told me earthquake nahi hai, volcanoes thi, hai na?
Yes.
My memory power has become good as well. The volcanoes, na? We will introduce the topic. Because ICSE, CBC, history, sorry, geography. So first we will understand what is the meaning of the word volcano, and then we will accordingly proceed. Attendance sheet ले विकास क्या है CBC. Okay, now what is the picture that he had seen on these volcanoes? How will you explain to me?
Volcanoes, it's like a huge opening in the ground that is caused because of the burst of lava.
क्या volcano lava ये ऐसा बोला तुमने? सर very bad experience. You tell me. Volcano is a
opening for lava to come out.
Opening for the lava to come out. Very good. Open करता आजा भैया lava to ऊपर. What kind of explanation is this, my boy? Look at the book and tell me what is a volcano.
A volcano is a vent in the Earth's crust from which fiery hot magma erupts from Earth's interior.
It is vent in the earth crust. Am I correct?
Yes.
In the earth's crust, through which what is coming out?
Hot lava.
Hot lava. Is it magma or lava?
Magma, say magma.
When it comes out, it is lava. Correct?
Yes.
Hot magma. I don't want to tell you. Correct?
Yes.
Oh, now he connects it. I do have a red pen. Okay. So I can color this. Correct?
Yeah.
It's not a color pen, but at least you understand. Anna?
Yes.
We'll use it. Why not? So this part is called as crater. Am I correct?
Yes.
This is crater. This is vent. And this is that hot lava or magma?
Magma.
Hot magma. Okay. And this is the lava. And when I look at this picture, we feel very simple. So it is so easy. But it is one of the deadliest phenomena on the Earth's surface. You ask it, is it deadliest?
Yes.
Besides this hot lava, what else makes volcanoes dangerous for human beings? I'm repeating my question. Besides this hot lava, what else makes volcanoes most dangerous for human beings?
Also like huge earthquakes.
In fact, earthquakes is the one of the cause for volcanoes. It is not volcanoes which cause earthquakes. Earthquakes might cause volcanoes. Very good. So,
First, earth will come and on top.
what a wonderful Bekar explanation.
The gases.
Very good.
Gases that are released because of.
Very good. Is it hot is very important or something else? The gases are poisonous.
Yes, poisonous gases.
And when it spreads in the air, it travels long distances. At least we can run away from the lava. But if it gets mixed with the air that we breathe in, it's very deadly for the human. Earlier, we have a person called, I don't remember his full name, but we have a scale which we use it, which we call it as a Richter scale.
Yes.
Oh, you know that, good. Any earthquake which measures more than 6, below 6, it is quite safe, they say. Below 6, it is quite safe.
Yes.
But if it is above, then the trouble starts.
Yes.
One, the earthquakes, when we measure on the Richter scale, it should be below 6. If it is above 6, then rumbling, shaking, and the earth crust also gets weakened. If I have many stratas or layers of the earth, not every layer is a weak layer. The movement of the magma is always there in CL, correct?
Yes.
But then it pierces out that part where we find the weakest part. Am I using the right word?
Yes.
It is the weakest.
The weakest part.
If it tries to spread here, it cannot come out. Why then? I said it is the underlying pressure of the big layers of the earth.
Yes.
Some people say when we are digging for constructing a huge, what is it? Skyscraper, we have to dig the.
Yes.
We are exposing the earth's surface. It might be one of the reasons.
Oh, so.
But then now the science is so developed, they might have already examined which part of the earth is not involved with which activity, volcanic activity. Even if their reports fail, then might they are adding to the causes of the volcano. Is it okay? So volcano, as he read, it is a vent on in the earth's crust through which the hot magma is pushed out. And if we say it is making a mountain or a crater, this part becomes a crater, the opening, the big mouth.
Yes.
Although I am showing this, but if you reality, you see it is very big.
Yeah.
And then if I want to explain 3 types of volcano, I can say 3 types of volcano. Any idea? The first one is active volcano.
Yes.
Second one is dormant volcano. And third one is extinct volcano. You understand the meaning of the word extinct? Now if I say active, it is Mount Kilimanjaro.
Yes.
In Japan. And some people is it Mount Vesuvius. And we have it in Andaman and Nicobar, one, barren island.
Yes.
So active means what? The activity of this magma is continuous. Few months before it exploded. It can explode any time. The movement is there. And the crater is also open.
Yes.
But it is only the time factor which might push this hot magma out of the earth's surface. So the activity is continuously going on. Explosion depends on the quantity or the intensity of the heat. But then we call that as which volcano? An active volcano.
Yes.
Did you guys understand?
Yes.
If I use the word dormant, I say it is nothing but it is a sleeping volcano. I understand the meaning of the word sleeping.
Right.
10 years before it exploded. 15 years before it exploded.
Yes.
But I can't take it for a ride that it is dead. It is sleeping now. When it gets awakened, it might become once again active. What does that awaken mean? So 10 years before it has exploded. But the scientists say that still the magma actions are going on.
Yes.
When it will explode, we do not have calculations. But for the time being, it is sleeping. Sleeping, so when it will get up, then it might explode. So the simple meaning of the word dormant, it is a sleeping volcano. And then the last and the most important, in fact, this is good for us, is it? It is an extinct, or other word I can use a word, it is a dead volcano. How do I use the word dead? 50 years before it exploded. 100 years before it exploded. Till now, there is no sign. But I can't keep it out of the race. It may, like we had Latur earthquake in Maharashtra. I'm not so sure it was in the year 1987 or 90, close to. It was a big earthquake. Then we had an earthquake in Bhuj, Rajasthan. Uske baad abhi tak aaya nahi. So the dead volcanoes are those volcanoes which might have exploded some 50 years or 100 years before. But actions hai, no hai, we do. But for the time being, they are regarded as extinct. For few centuries or for few decades, against the centuries, few decades it hasn't exploded. Understood? It hasn't exploded. So that is the reason we say it is a which volcano? Extinct volcano. Understood? So one is active volcano, dormant volcano, and extinct volcano. You got a picture?
So it's like the extinct volcano is just like dormant volcano, but that has not.
No, dormant was maybe 5 years, 10 years. The gap is not big.
Yes.
Extinct, the gap, the time gap is very long.
Oh, okay.
When your father's dad was alive, that time it exploded.
Oh.
Your grandpa died. This is father's dad. But till now, you have also seen it. Your grandpa might have told, "Beta, jab main jawan tha na, it had exploded." But after that, there is no sign. But till I am alive, I didn't see. Your grandpa might have passed away. Your dad, you also now maybe close to 15, 16, there is no explosion.
Yes.
So then 3 generations have seen, close to. Then they say this is the extinct one.
Oh.
But your dad has seen it, and you were too young. So I might put it into not extinct. Sleeping in. Geographers keep signaling. Be careful, anytime it might explode. For extinct, they will not say anytime it might explode.
Yes.
They might have observed for last few decades. That is why they branded that as which volcano? Extinct. What dead? But dormant, they will not give you any warranty or guarantee. What is that word warranty? It might wake up.
Yes.
But before it wakes up, they will tell you 2 weeks, 3 weeks before. But then the danger is always there. Active, no push.
Yes.
It is always active. So generally, human settlement or inhabitants or the people are asked to stay away from such kind of volcano. Why? One, it bursts with thundering and loud noise. 2, the lava comes out, that's one, but it throws lots and lots of poisonous gases.
Yes.
Which might spread in the air and can remain as a cloud of dust, which might be highly suffocating. You understand suffocating?
Yes.
So that is the reason volcanoes are directly and indirectly dangerous for any human settlement. Is it okay?
Yes.
So let's write what is volcano first. And I'll ask you to draw a small picture like this. It is there in your volume as well as in the textbook. Okay. So write down the meaning of the word volcano first. It is a vent. Volcano is a vent on the Earth's surface. through which the hot magma went on the Earth's surface, through which hot magma is thrown out from the Earth's interior. Is thrown out from the Earth's interior. Next point. These are sudden movements which are associated with the internal forces of the Earth. These are sudden movements which are associated with the internal movements of the Earth. Sudden movement associated with the internal forces of the Earth. Next, causes of volcanoes. Point number 1. After writing the causes, will you draw the picture or you want to draw the picture right now?
After writing
Causes, are you sure? So please, point number 1. Heat and pressure inside the Earth. Heat and pressure inside the Earth. High temperature and extreme pressure. High temperature and extreme pressure within the surface of the Earth. Keeps increasing. Keep increasing or keeps increasing. Come on, towards the center. Keeps increasing towards the center. Full stop. Second point. The intense heat, second point. The intense heat melts the underlying rock structure. The intense heat melt, make it plural. Huh? The intense heat melts the underlying rock structure. Bracket, you write, rocks are bad conductors of heat. Would anyone complete this one? Rocks are bad conductors of heat. So, along with the melting of rocks, next one. Along with the melting of rocks, it also build intense pressure. There also builds an intense pressure. Ready to explode. An intense pressure, ready to explode. What is that bad conductor of heat? I don't understand.
like it can't pass on the heat through.
So what will happen?
So it will absorb the heat.
Very good. This is what I want. So I said there is a rock structure like this, two rock structure, and I'm applying intense heat. If it is a conductor of a heat, it will absorb and pass it to the next layer.
Yes.
And this might pass it to the other layer. But since it is not absorbing the heat, it will melt.
Yes.
We imagine if a rock structure is melt, what might be the average centigrade heat?
It's very good.
Very high. Yes, if you remember that Earth's centigrade.
26,000.
3,000 to 5,000 degrees Celsius.
Oh.
We get only close to 33 from the sun,
Yes.
or maybe 34, sometimes 34, 35. How do you feel?
Very hard.
Scorching, intense heat. Imagine it is 3,000 or 4,000 degrees centigrade. So rocks are nothing in front of that heat. So it has to be melted. It is melted now. It is in that boiling form.
Yeah.
But along with melting, there is also huge pressure which is built. You understand the meaning of pressure? So it is always the pressure is mounting, mounting, mounting. So it will always try to heat the earth structure which is compressing it. It's like if you have seen an LPG cylinder at home, it has a regulator.
Yes.
What does the regulator do?
Controls the pressure.
Wonderful. And it is in the liquid format.
Yes.
Since it gushes with great speed, it converts from liquid to
Gas. Yes.
so the rocks are converted into liquid, no issues. But then the pressure is mounting there. So this pressure is something which is really a dangerous one. And when this rock structure might have melted, rocks might be having some good compounds and bad compounds.
Yes.
So these bad compounds might yield to poisonous gases.
Yeah.
Are you not there also waiting? And pressure is boiling, boiling. One big blast. The mountain pressure has released the poison gases to a distance.
Yeah.
Some people ask me, sir, can we have a volcano under ocean?
Yes.
How come? It is the water.
So hard that the water will not.
In fact, I have not now. I got a very rare video of a underwater volcano beneath the ocean.
Oh.
Now, beneath the ocean, the volcano pushes out the magma, but the water is there. But the entire water structure becomes black ash in color, complete black.
Yeah.
Look, gallons and gallons of water that can also not prevent what? Volcano from busting out.
Yes.
So imagine what is the pressure of this? What? This heat. Might be the gases might not be thrown up.
Yes.
Because it is not free. जैसा भी earth structure is free है. उठा के फेंकता है. Lava also comes out.
Yes. So
It's like that boiling pot. आपने देखा भी रहेगा. That lava, small patches jumps up, and suddenly it flows up.
yes.
If I want to show you ocean one, it might not push out the gas,
Yeah.
but at least it is pushing out what?
So,
It might cool as compared to the earth structure a little bit faster because the water is there. A little bit faster, but it takes few weeks or few months. But then in between the ocean, what are we having? Some rock structure.
yeah.
Maybe in future, if the water level goes down, what this might become? An island.
Yeah. It will become like that.
Are you understanding what I'm saying? It is a volcanic erupted island.
Yes. Yeah. Most of the
When I explained that landforms, if you remember the last part of the landforms, I said significance. The beauty of the significance, some forms are created, some forms are destroyed. And if you have a volcanic erupted island, what a beauty it might be. So the island I say bana hoga, maybe we do not know.
yes.
Some islands are submerged peaks of the mountains,
Yeah.
like Andaman and Nicobar.
Yes.
That's why they are huge, extensive. 500 plus islands are there in Andaman and Nicobar. Out of which only 238, I'm saying 238 is only inhabited. Inhabited means ऐसा नहीं कि बहुत inhabited होते हैं.
Specific.
Only specific, like we have Port Blake, the main city. That's quite okay. And 2-3 islands even I found quite okay. Hardly 300 family रहते हैं.
Yes.
Imagine 300 families in our area. एक building में 500 family रहते हैं.
Yeah. That's
I don't understand it. So this is what we are trying to understand, that rock being a bad conductor of heat, it cannot absorb. So it has to melt.
Yeah.
Is it going in front of the whom? The intense heat of the earth? Yes. अगर आप मुझे absorb नहीं करेगा, तो आपको मैं क्या कर देगा? Melt कर देगा. We are quite happy with the melting of the rocks, but we are not happy with the gases which is formed. That adds to the danger of the volcanoes. So,
Yes.
from where we get this poisonous gases? Let's write second point. Plate tectonics. Plate tectonics.
Yes.
It is one of the most important reasons for the volcanic eruption. Just which takes place near the plate margins, which takes place near the plate margins. If you remember, I have explained 3 types of plate tectonics. You remember?
Yes.
Coming closer is what?
This convergence.
Very good. Going away
Diverging.
and slipping one another. Transform. Now I said that the volcanoes might take place if the 2 plates are coming nearby. These are the, you remember I have said convergent margin.
Yes.
This is the margin. Already these lava and magma are all right here, and these are slowly moving. So it might add up to pushing the lava little bit higher, and then suddenly it might burst. If I said moving away, so 2 plates were tightly packed, something like this, correct?
Yes.
The lava actions are here, but now they are moving away. They are asking, "Bhaiya, aa jao." There is a passage now.
So there's like intense.
Intense heat is going on, and these plates are moving away.
So the thought might go
Only from here, it will not burst from here because these plates will not allow them. But where is the space created, it will come. And if I want to say transform, you remember 2 plates?
Yes.
1 plate slipping down.
Yes.
This is the passage.
So like it's down.
This one, suddenly this is slipped down. There is a gap. So the lava might come out like this. So it always comes from the margin, not between the 2 plates.
So it just finds any way to just get out.
Anyway, it is either moving closer or moving away or slipping down. It will always come from the margins only. Which margin?
The margin between
The plate margins. Read it silently.
Yes.
Plate margins. Okay. Next point, same reading. The same forces that causes the earthquake also causes volcanoes. So they go more or less both are closely connected with one another. What are connected? Earthquakes and volcanoes. The last one, magma chamber. Magma chamber. Let me pick up any, since he was absent on that day.
Yes, magma chamber, right?
Magma chamber. Write the explanation for magma chamber. It is that part of the Earth's crust where the weak rocks, are in the form of molten state. And creates a huge chamber for itself.
When it comes down to it, there's not a lot of things that can change.
So we have a wonderful explanation.
Causes
Huge chamber for itself. Underline the word chamber. Next point. Fresh magma. Continues to pour. Fresh magma continues to pour, adding to the chamber. Full stop.
yes,
It contains, next one, it contains silicate, gases, and water vapors. It contains silicate, gases, and water vapors. So, continue, same point. So, it rises vertically upward. Leading to a volcanic eruption. Now read this and tell me, how does molten magma chamber leads to the volcanic eruption? I've given it in the most simplest format, so you can draw the picture afterwards. Let us understand with an explanation what is this beautiful fellow is trying to explain. Okay. Oh my God.
Change the world. If you exclude extraterrestrial things like the sun, moon, or an asteroid, then the list becomes pretty small. And if we talk about change that had an observable impact in our lifetime, well, excluding ourselves, the only thing left over are volcanoes.
Is it okay? Quite okay?
Natural disasters can have truly devastating consequences, but only a strong volcanic eruption in the right place can have consequences for everyone, everywhere. But why do volcanoes even exist? Where do they come from? And why are some different from others? The heart of all volcanoes is their magma. As a kid, you may have wondered if a volcano would pop up randomly nearby where you live, and maybe question why that doesn't happen. After all, magma clearly comes from inside the earth, so what's stopping it from coming to the surface here? Well, magma isn't actually abundant in the interior of the Earth. So where does magma come from? The collection of tectonic plates on which we live comprises what we call the lithosphere. These solid structures sit on the lower, more viscous asthenosphere, or the upper layer of the mantle. As these plates slowly move around, they bump and force themselves into each other. If one plate is denser than the other, it can be pushed underneath the less dense one. There are two main compositions of plates, those with denser oceanic crust and those with less dense continental crust. Oceanic crust is mostly mafic in composition, which means there's a lot of magnesium and iron, which forms a nicely organized array with other
magnesium and iron.
Continental crust are more felsic in composition, which means a lot of silicon is present, forming large complexes of tetrahedral networks and cations. Because of their different compositions and densities, if these plates collide, the ocean plate will be pushed down underneath the continental one. This behavior can also occur when two oceanic plates meet, and we'll discuss this a little later. Now, when we look at a map, we can see that volcanoes predictably exist where oceanic plates meet continental plates. What processes cause this? As an oceanic plate subducts beneath a continental plate, it experiences both an increase in temperature and in pressure. The composition of the subducting lithosphere isn't much different from the asthenosphere, so this heat and pressure increase shouldn't be much of an issue. But during subduction, the lithosphere brings with it contaminants other than just the silicon, oxygen, and cations forming up their structure. The two primary contaminants we are concerned with in this process are water and carbon dioxide. Before we discuss their role in magma, let's appreciate the intuition of why contaminants change the physical properties of whatever they happen to be contaminating. We'll look at the example of salt in water. When we freeze water, the molecules within organize to form this solid lattice structure. Now, if we imagine a contaminant like a salt ion, this disrupts potential hydrogen bonds from forming. So it makes more sense for the nearby water molecules to detach and remain liquid. Not only can they form pseudo-ionic bonds with this ion, but their mingling also increases the average amount of hydrogen bonds they can create, thus producing more stability. This principle holds true to any contaminant in any material. As the contaminant disrupts their lattice structure, molecules in the material can achieve more stability by interacting in the liquid form and remaining in their solid form. Thus, contaminants cause a breakdown in lattice structure quicker, or in other words, lowers the melting point. As the pressure and temperature increase, the water and CO2 molecules within the lithosphere enter their gas phase. But due to the extreme pressure, there's nowhere for them to go, so these contaminants stick around and disrupt the lattice structure of the lithosphere material. This causes it to melt into a semi-liquid phase. Since liquids are less dense than solids, this semi-liquid magma slowly begins to rise back up towards the surface. Eventually, the magma will reach the Mohawk discontinuity, or the bottom of the crust. Because the crust is less dense than the mantle, the buoyant force pushing the magma to the surface weakens, and as a result, the vast majority of formed magma begins to pool up here. In fact, most magma never reaches the surface. It simply solidifies and crystallizes here, mixing with the surrounding material. If, however, enough magma pools up underneath, the upwards force can cause enough stress on the crust to cause cracks and fissures to form, at which point our magma can continue to rise. This process creates the magma on tectonic plate boundaries. But you may have noticed on our map, or simply know, that there are volcanoes in the middle of tectonic plates, like the Kilauea volcano in Hawaii. Some magma actually can come from within the Earth itself, in the form of a hotspot. Although the mantle is technically not a liquid, over geological time periods it behaves like a fluid. As a result, when the internal heating of the planet isn't uniform, a section of mantle will become warmer than the surrounding mantle. As a result, this extra heat makes this section of mantle less dense, which then causes it to rise. Normally, the temperatures within the mantle would be enough to melt it, but the extreme pressure prevents this. However, as the warm section of mantle rises, pressure decreases, causing decompressive melting into a more liquid composition. As a result, it becomes even less dense and rises even faster. Eventually, it too reaches the Mohawk discontinuity, and after enough has cooled, it will force its way to the surface. The coolest thing about hotspots is that you can see the path the tectonic plate traveled above it as the column underneath it continually poked up at it as magma. So now that we know where magma forms, we probably want to know what makes them different. Why are some volcanoes effusive and others explosive? This property is tied to gas content in the magma. Remember, carbon dioxide, water, and these other gases I haven't mentioned all accumulate with the magma in the magma chamber. And And just like a carbonated beverage, the gas would like to leave, but it's held in place by the pressure surrounding it. So very similarly to opening a shaken beverage, if the pressure is suddenly reduced, like the rupturing of an overhead rock ceiling, this decrease in pressure causes gas to escape and expand from the lava. The expansions inevitably expose more lava to the air, which causes more gas to escape, causing more expansion, and so on, and thus you have an explosion. So the more gas in a magma, the more explosive it is. But what dictates the gas content of a magma? This property is controlled by the magma's viscosity. Strongly mafic or liquidy magmas have very small solid fragments within them, hence why they behave like a liquid. As a result, it's very easy for gas to escape and interchange with its surroundings. However, very viscous and felsic magmas have very large crystallizations and solid complexes within them, making it more difficult for trapped gases to find their way out. So the higher the silicon oxide content and subsequently the higher the viscosity, the more volatiles or gases that can be trapped inside. Therefore, it is these highly viscous felsic magmas that are responsible for the strong explosive eruptions that we love. Finally, the last question to ask is, what dictates what kind of magma is formed? As magma passes through and interacts with the overlying crust, it melts and incorporates a lot of the crust material within the magma itself. Since roughly 90% of magma that reaches the surface forms in the ocean, most of it is of liquid mafic composition. Earlier we mentioned that two oceanic plates can heat up, and whichever plate is denser will subduct underneath to form magma. As a result, the rising magma interacts with mafic ocean crust. Therefore, volcanic islands like the Galapagos and the Aleutians all formed from mafic magma and experience effusive eruptions. However, when magma rises through and interacts with continental crust, not only is continental crust thicker, it also has a high silicon content. Incorporating the silicon makes the magma more felsic and thus more viscous. An easy way to determine eruption type of a volcano is by its shape. Steeper volcanoes or stratovolcanoes generally are explosive, whereas shield volcanoes with low grades and wide bases are effusive. Stratovolcanoes are of utmost importance because they can send cubic kilometers worth of material into the stratosphere. While suspended at high altitudes, this material reduces solar insolation and subsequently cools the entire planet. Paleoclimatologists believe that ancient volcanoes roughly 250 years ago caused the worst mass extinction seen, resulting in the end of the Paleozoic era. And a little over 200 years ago.
So the entire video explains how is this magma is formed. Okay. This is actual pictures of Yellowstone exploding magma. Let's see this. The largest magma chamber on the planet Earth.
When I was a student, I read.
So just now we have done what is magma chamber. They're explaining that magma chamber.
The immense large quantities of carbon dioxide gas from its shallow magma chamber only 5 kilometers beneath the surface. Its magma chamber is unusually large, containing 10 cubic kilometers of molten rock. However, among active volcanoes, other systems around the planet contain even larger bodies of magma. For example, the Yellowstone supervolcano in Wyoming has 2 massive magma chambers which total 46,000 cubic kilometers of material. However, this is still not the largest magma chamber on the planet. For that, we need to travel to a remote location in the central Andes. There, a large area is being slowly uplifted due to an underlying magma chamber with an impressive volume of 500,000 cubic kilometers of molten rock. That is enough volume that if it was to all erupt, it could hypothetically cover the entirety of the United States to 131 meters or 430 feet of lava. So, why does this magma chamber exist? Is there any danger of an eventual eruption? This video will answer these 2 questions and discuss this fascinating feature. This massive magma chamber is located across a wide swath of the Andes mountain range, where parts of it are located in Chile, Argentina, and Bolivia. As we zoom in, you can see that this magma chamber is divided into 2 parts. The northern section measures 340 kilometers wide and 180 kilometers long. In total, it covers approximately 60.
If
February 1942, Mexican farmer Dionisio Pulido thought he heard thunder coming from his cornfield. However, the sound wasn't coming from the sky. The source was a large smoking crack emitting gas and ejected rocks. This fissure would come to be known as the Volcano Paracutin, and over the next 9 years, its lava and ash would cover over 200 square kilometers. But where did this new volcano come from, and what triggered its unpredictable eruption? The story of any volcano begins with magma. Often, this molten rock forms in areas where ocean water is able to slip into the Earth's mantle and lower the layer's melting point. The resulting magma typically remains under the Earth's surface thanks to the delicate balance of 3 geological factors. The first is lithostatic pressure. This is the weight of the Earth's crust pushing down on the magma below. Magma pushes back with the second factor, magmastatic pressure. The battle between these forces strains the third factor, the rock strength of the Earth's crust. Usually, the rock is strong enough and heavy enough to keep the magma in place. But when this equilibrium is thrown off, the consequences can be explosive. One of the most common causes of eruption is an increase in magmastatic pressure. Magma contains various elements and compounds, many of which are dissolved in the molten rock. At high enough concentrations, compounds like water or sulfur no longer dissolve and instead form high-pressure gas bubbles. When these bubbles reach the surface, they can burst with the force of a gunshot. And when millions of bubbles explode simultaneously, the energy can send plumes of ash into the stratosphere. But before they pop, they act like bubbles of CO2 in shaken soda. Their presence lowers the magma's density and increases the buoyant force pushing upward through the crust. Many geologists believe this process was behind the Paracutin eruption in Mexico. There are 2 known natural causes for these buoyant bubbles. Sometimes new magma from deeper underground brings additional gaseous compounds into the mix. But bubbles can also form when magma begins to cool. In its molten state, magma is a mixture of dissolved gases and melted minerals. As the molten rock hardens, some of those minerals solidify into crystals. This process doesn't incorporate many of the dissolved gases, resulting in a higher concentration of the compounds that form explosive bubbles. Not all eruptions are due to...
At least you got a better idea what it is. In fact, the first one was very detailed, but he was trying to explain where is this magma formed from. Whenever that water escapes deep inside the Earth's surface, it is going to, already the interior is hot, okay? And it is going to, in between the layers anyway, it is going to create some hot bubbles.
Yes.
Are you not understanding? So that is how this, what is caused? Magma, which is rising with bubbles, and they have shown some water bottles, if you remember. What is that water bottles are? What is that water bottles are? It's more like showing you, what do you call it? That when I open a soda bottle or anything,
Yes,
the filled in gas, it is going to bust up.
Yeah.
So whatever gas is formed below the surface of the earth, along with this molten magma, it's going to erupt. It's okay?
Yes.
So let's proceed. So draw this picture as it is in your notebook. Magma chamber, the vent, and no need for this squarey one. I don't understand it. This mountain, crater, and everything. Start. Like I have drawn it, but you need to show the magma chamber. What a detailed or a rough picture of that. Use your volume or the text. Then we have types of volcanoes and effects. Show the magma chamber, show the vent, show the lava, try to mark the crater. Everything, it should be neatly on one side. That's not allowed. Take a magma chamber, make it clear as he is making it. The diagrams they carry marks, man. Erase the entire diagram. He's making neatly. So many pictures and videos I've shown, and you are making a mess of the diagram. That's not allowed. Okay, so after this, you want me to go back to earthquakes, or you want me to earthquakes is not there for the coming exams? Are you sure? So volcanoes is the last topic.
Yes. So that's the last topic.
Shall we? And when is the exams are planned, by the way, next month? Coming month, it's July, is it?
Yes, July.
10th. Tomorrow it starts. Oh my dear. And when is geography? Tuesday means the coming week. So we have Wednesday. So almost 6 days are left. So are you going to come for the lectures in between your exams, or you're going to take a dip? I think it's not an exam, it's a class test. How much marks it carries? So I think you're quite okay. You can come and attend the lectures. All the lectures, not only for me, I must.
During my exams, I'll be coming for all the lectures.
That's the bravest part. You don't take a leave. If you feel that tomorrow the exams are difficult, then you sit. If not, try to attend. This is the first school exam. Which school are you after? Where? Then you stay here. You travel on the school bus. And yours is?
Same days.
Oh.
Sector bus.
It has only ICSE or state board as well?
Same days. Same days also has like a, I think, state board branch in Bashi.
And this is also a sector 10 in Kopaken.
Yeah, sector 10 in Kopaken. One is in Bashi, that is state.
That's only for the state.
Yes, and one is here, that is
ICSE. And one somewhere which may be CBSE.
Yes, which
You may not have. Yes. So same time maybe is a good. So write down the next heading vent. You can't vent लिखने के जगह पर you write down structure of a volcano. Yes. So it will cover both structure of a volcano. What do you mean by structure? How does it look? You know?
Yes.
Or what are the parts of a volcano? So first we will write vent. Okay, where is vent? Is this the vent? Can you use it as a narrow pipe
Yes.
or a narrow passage through which water is pushed out? Magma is pushed out. Very good. Right on. Vent is normally described as a narrow opening found in the Earth's crust. A narrow opening found in the Earth's crust through which hot magma is pushed out. Full stop, one more sentence. It is usually appears like a circular pipe. It usually appears like a circular pipe. It usually appears like a circular pipe. It usually appears like a circular pipe. Next, you can write volcanic cone. Next, it is a volcanic cone. You understand the meaning of a volcanic cone? Is in the picture, are we having it? This is in fact, correct? Is it more like a cone? It's like this. And the top part is open. Why top part? Because through which the lava is bursting up.
Yes.
So this is the place where we are referring to volcanic cone, right?
Now always come from the top.
That's a wonderful question. Now when I use the word vent, I can't have a vent like this. It might be a funny vent.
Yeah, that's not possible.
And even if I ask the magma ICSE flow karne ka, do you think with such pressure it will take a U-turn and then it will come up? Take a water pipeline or here.
So,
It is having so much built up pressure. One small surface it will come out bursting. It's like I have pushed you inside the room and there is only one door here. This is the only opening. And the time you get, you will just open this door and rush away.
yes.
But do I think you will break this and rush away? Is it possible you will come and break your head only?
Yeah.
Because this is the weak part. I said you are going to push out, open. You just push out. So straight ही भागेगा ना तो ऐसा वैसा turn मार के क्यों भागेगा? I don't know. You got a very wonderful laugh. Is there any other such extraordinary thoughts, man? अरे but उधर weak नहीं है ना, that's crust. ये weak नहीं है. This part is not weak. Only this part is weak. Like where from the weak you will trespass through that only. If it is strong area, you go and bang, you are going to break your crown only. It is not pahadon pe aata hai. Because of that volcano only it has become a mountain. Might be in the mountain, some parts might be weak also, we do not.
Yes, that's why there are chambers.
Correct, the chambers, magma chambers. It's not like that every time it comes on the mountain only. It can come on a flatter area, but for years it comes, automatically the lava piles. After long distance, you can see some volcanic mountain. I mean, volcano gushes out, somebody आके ऊपर से दम मार के उसको plane तो नहीं करेगा.
Yes.
Who has the guts to go there? Even after months, you can see even after 6 months, the temperature of that magma or the lava is close to 500 degrees centigrade.
Yes.
The 500 में did you not see? It is animated only. You can't even touch. Forget about touch. You can't go near. आप अभी जब winter में when we create fire, when we put more logs of wood, how the induction, the heat is correct. You try going near to a 500 degree centigrade, what will happen? You might burn yourself.
Yes.
That's why the coat or the jacket they are wearing absolutely heat proof. Got it? So right on the volcanic cone. ये now पहले से था वैसा कर दूँ चलो. ठीक है, I will continue this in the next section. We find this break. You take your break and then we'll go ahead. Okay, and try to finish all the answers of this whatever we have completed. Got it?
Yes, sir.
चलिए, thank you and good luck for your